going to drive deeper into one specific finding so that we can explain a specific analytic and how it works and some of the benefits around those. So I'm going to focus on, again, AHU 1 serving these administrative work areas. And by expanding it out, you can see there's a number of opportunities that have shown up, from duct static pressure control to simultaneous heating and cooling. So I'm going to specifically focus on the finding that's producing, in this case, over $2,000 in energy savings opportunity according to the analytic. So you can double click on that finding and the software automatically takes you to a deeper level of analysis inside the analytics performance dashboard. And this provides you more context, more information around what the problem is that's occurring, how you can determine what the root cause might be, what the corrective actions might be associated with that cause, and what the energy savings opportunity could be for that analytic, which might allow you to collect utility incentives and determine what a return on investment might be for correcting that issue. So specifically in this dashboard up on the top, at a high level we're showing how many analytics are executed on that specific air handler, how many have failed either in the period we've selected, which was the past month, or how many are currently failed. So just for this specific air handler, there are 3 analytics that are currently failing out of the 20 deployed. And over the past 2 weeks or so, 10 analytics have failed. So this one finding is showing potential energy savings over the past couple weeks of over $2,000 in savings for one specific finding. So it just shows you that the amount of opportunity that may exist with this one piece of equipment may be substantial. So in the bar on the top of the screen, we're showing some more description around the specific finding. So in this case, mechanical cooling was sequenced on prior to outdoor air dampers opening fully while the economizer sequence was enabled. So that speaks to a potential issue with damper control, mechanical cooling control or sequences. And it may, like it shows, identify an opportunity for potential energy savings, especially during swing seasons like the spring and the fall. But once a person's able to identify this issue, the next question that comes up is how can we determine what's causing that issue and how can we get it fixed? So the tools on the bottom half of this dashboard really provide you the information you need to achieve those things. On the bottom left-hand side of the screen is a transitions dashboard, which gives you a list of all the different instances when that analytic failed and when it transitioned back to a normal state. And this allows you to potentially uncover patterns in when that issue is occurring. Certain issues may occur at startup of equipment, may happen during the middle of the day, may happen at night when the equipment maybe should be off or cycling. So this gives you more tools to narrow down on the potential root cause of the issue. But by focusing in on a specific instance of failure, you can see that this pane containing analytic probable causes shows up. And we can focus in on those potential causes by maximizing the pane. And you can see here we get a list of 5 potential root causes for this economizer and mechanical cooling issue. And they are rated with a likelihood based on a variety of different information contained within the equipment and also within the analytic itself. So you can see, for example, this issue might be caused by a poor cooling sequence of operation or a mixed air temperature set point that might need to be improved. It could also be caused by a chill water valve position that was overridden, and some others are listed with lower likelihoods. But this allows the person who's actually trying to diagnose the cause of the issue to have more context around it and identify what actually is going on with the equipment.